Oh, popular astronomers, you can't beat doing your astronomy show alongside a spinning washing machine. It's got 1 minute left on it. I think it's about to do that hyperdrive cycle, though. Oh, my God, hailstone on the window. Wow, we've had a really, really stormy day here on Anglesey. That frightened the life out of me. You probably won't be able to hear it over the sound of the washing machine and me gabbing. It's about to get really noisy in here, popular astronomers. In the meanwhile, while it's teeming down with hailstone and the washing machine is on full spin, we're going to play the countdown while people join the feed. Oh, my word. Never a dull moment on this show, eh? And laundry. You can't beat it. I know Naga Munchetti has those on her rider. She insists to have a washing machine and hailstone in the background of every broadcast. It said it when they had 1 minute left on it. So good evening, popular astronomers. Welcome to the chaos that is Pop Astro Live. Straight out the traps, it's chaotic. Do you know what? How much I have meditated to this absolute precise moment in time and envisioned a calm show with nothing going wrong, and instantly the fun starts. So how are you, popular astronomers? Hello, let's have a look. Loads of comments. Hello, Vernon, you're on time. That's really good. I'm very glad. And I have started some other audio off in my headphones. I can hear another video playing. I've got my own voice in my headphones. Excuse me 1 minute. Let me just take these headphones out. Where is my own voice coming from? What is happening? Sonia, hello, good morning. Good morning. Should we start again? 3, 2, 1. Good evening, popular astronomers, and welcome to Pop Astro Live, the live astronomy chat show, possibly the hottest astronomy show in the known universe. Tonight, we have got a scalding hot lineup of amazingness for you. Hurtling onto your screen this week are two spectacular guests. First, we've got Carolyn Crawford, communicator of science. She's an astrophysicist, researcher, lecturer and public astronomer based, it's going to start beeping now, that washing machine is, at the Institute of Astronomy, Cambridge. Carolyn's specialist subject is one of the best words in the entire universe to say, Oumuamua, the mysterious interstellar slab that hurtled through our solar system one time only. Our second guest is Mark Sephton, professor of organic geochemistry and astrobiologist as well. Mark is a team member of the Mars 2020 Rover Science Team, and it's his job to help select those elusive and incredible samples that will eventually one day make their way back to Earth. So Eleni will be along to brighten up our lives like the human supernova that she is. I think that name is going to stick. I told you to start beeping. Let me just go and alter the... Switch it off. Switch it off. Come on. Why do they have to beep? Why does modern equipment have to beep? I know it's finished. It doesn't have to beep continually, does it? Then we've got Eleni. She's bringing us the space news, space weather and space traffic and travel. And then finally, seeing us out, it's Sonia Turkington. She has got the observing forecast for the week. Are we going to be seeing much sky? And she is definitely one of the SPA's newest and keenest members. And she'll be doing a presentation called The Reason for the Seasons. So as you can see, the chat room moves as fast as Oumuamua. Cosmo the telescope sloth is back from his adventures. Did you see what I did to him this week? He said he doesn't want to go in the microwave again. We microwaved Cosmo. We'll come to that bit later. And I am Vicky Duncalf, astronomer, botherer, royale. I've called myself for many, many years. Let's see who is on the chat. Hello, Catherine. Greetings from Kathy and the Ragdolls. Hello to you. Good evening, Vicky. Thank you, Kath. Look, I've got my sundial necklace on, which we shall come to in a little bit. Hello, Colin. Good evening, Vicky. Nice to see you again. Looking forward to tonight, as you should be. Hi, Vicky from David in Bath. Not done much astronomy due to cloudy skies, and my attention has been deflected by volcanic activity lately. In particular, Mount Etna, Sicily and in Iceland. Very good. Fantastic, Dave. I was gutted it was cloudy. Alan, you sure it's the headphones, Vicky? Yeah, I could hear one of my videos that I've got saved on my laptop coming out. Let's see if they'll come back on now. Don't need to hear myself playing a video of myself. Right. Okay. Anyway. Oh, we've got Robin. We might, in a minute, be getting a live view of the ISS going over if Robin's picture starts working. Robin, are you there? Is Cosmo still in the microwave? No, we salvaged him. But he has been off to some very far-flung places this week, and you are going to have to guess where he's been to. Okay, so tell me what you have seen in the sky this week, please. Let me just change my banners here. Okay, so drop into the chat what you saw. This week, I'm not best friends with the moon, although that is pretty cool, isn't it? It looks amazing on photographs. This is a cheap one. You want to get a USB one. You don't want to get one that takes AA batteries. Let me turn out the light and I'll show you how good this is. It has got a remote control and it does change colour, but I've not brought it. Let's have a look. Look at my moon. Now, if you've got a decent phone camera, oh, there you go. Look, how beautiful is that? I think it was from B&M and I think it was £6. And there you go. Look, it's a badly printed, cheap facsimile of the moon. But if you get a decent one with a USB charging port, I think it's going to be really good. I wish I'd got the 20 quid one rather than the £6 one. Now it's got like a mucky old line along it, but that is the moon. And you don't need me to tell you that is the moon. Unless you're a very, 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 very new astronomer. So I'm just going to turn on the heater. Excusez-moi. This is quite warm in here, actually, for a change. So I got the moon. I've got the whole moon in my hands. Okay. So, yeah, this is what I saw this week. I saw the moon when it was about half full in exceptional detail. And our lunar section director, David Graham, did a post about how exquisite the moon was. And it just so happened that I have my telescope out and oh my gosh, when that terminator is like running down the center of it and bringing all those craters and mountains and mares into the sharpest relief. Wow, my love affair with the moon is back on after many. You see, I've only just got my telescope about maybe about a year ago, actually. But I equate beautiful starry nights with good astronomy, and when the moon comes up, my telescope doesn't work very well, so I'm falling out of love with the moon, but I'm back in love with it now. Sandra, I've been meaning to tell you, you are going to love tonight. We've got Mark Sephton. Is it Sephton? I've got his surname now. On later on, we are going in detail on Mars, and I know how much you love Mars. So David Deegan, just a faint moon through the clouds tonight. No chance of seeing the moon here. Raining again in Bath. It's a very wet place, Bath is. Okay, so plug the mug. Oh, two-timing me with Julian onions, are you? To be fair, I'd two-time me with Julian onions as well, actually. Sorry I'm late, but just had to pop in to see the beautiful Julian onions talking to another astronomy society. Could only see him for 1 minute. I was at the national. Oh, wow. Check you out, Wendy. And Wendy, thank you so much. I'm going to let you plug the mug for me. Why have a dog and bark yourself and plug the mug when we can show Wendy's beautiful picture of the mug that she has bought from the SPA? Let me see if I can do this. Share the screen. Share screen. Now, with a bit of luck, please work. Please work. Just work. Go on. No, it's gone wrong. Right. I can't do it. You're looking at my Facebook. I've got beautiful pictures of Wendy's mug. I've just closed my PowerPoint down now. Aha, the screen share on this thing is erratic. More erratic than me, even. So I think we're going to go over to Robin now and see whether we've got a live view of the ISS. But thank you, Wendy. I know you bought a couple of SPA mugs and you had a lovely picture of Elmo, the Sesame Street puppet, sat in bed drinking hot liquids. It was wonderful. How's it going, Robin?
Hi there. Can you see the picture? Yeah, you can. That's it. Right. Well, I can't see it yet, but oh, wait a minute. I've just spotted it right down there. Just above the conservatory. Can you see that? It's moving quite slowly at the moment. You can see the stars, I guess, quite well, can you? You can see the Pleiades and Taurus in the middle of the field view. What? Sorry?
Where is it?
Where is it? Right. Well, it's right down in the middle of the field of view at the moment, the ISS, right above the conservatory there. Can you spot it? That bright light.
Oh, look at that. No other astronomy show in the universe is showing the ISS at the moment, I don't think, is it?
And it'll just take a second or, well, a minute or two to go. And it's going right overhead from here in near High Wycombe tonight. I'll leave the camera static so that you can see it moving.
That's beautiful. Can you see the battery pack in front of it, Robin?
What battery pack?
So Liam Kennedy, who we had on last week, who's the inventor of ISS Above, the ISS tracker, said that they ejected a battery pallet last week, and it should be about 1 to 2 thumb widths in front of it, or at least it was last week anyway. So look in front of it, you might spot something.
Well, if I brighten up I'll change the shutter speed to, no, I can't see anything there. That brings out fainter stars than I can see with the naked eye. And
that's really cool, Robin.
Ahead of it at the moment.
That's really, really good.
You can see some quite faint stars here, can't you? I just missed that star. Wow.
Just missed it. Thank God for that. What a mess it would have made in the sky.
As I pan up, you can start to see the constellation of Auriga up there, and it should go just to the left of Capella there. So there we are. And so that is, well, I haven't got my facts and figures ready with me, but it is probably about 240 miles up at the moment. And do you know, I can't remember how many crew members there are on board. There's probably about 6 people on board. And as they watch, as they look, they will still be in sunlight, as you can see, because the space station there is shining brightly. But now it's pretty well overhead. It's just gone past Capella there. And I've got the camera pointing right overhead now. In fact, I can't get any higher myself. So,
Robin, that is a fantastic pass. What a fantastic pass as well.
Right overhead from here.
Oh,
I'll let it drift out.
Amazing.
So there we've seen it. Now I might swivel the camera around and just catch it from going over again. There we are. And you can see the moon is down there to the lower right. And I guess it will start to fade out within a minute or two.
Can everybody who is watching this now, live and pre-recorded, give it a good old wave. Wave! Thank you, ISS.
Hey, there's another satellite going past as well. Can you see that one just to the right of it?
Oh, wow. What a brilliant cosmic collision. That was fantastic. It's blooming bright, that is. It's really good. Sonia's waving.
So there we go. The prediction shows that it should be fading out about now. You can see it is getting a bit fainter there.
Oh, Robin, that's so good.
Earth's shadow around now. They are fading out. So there we are. We brought you the ISS live on Pop Astro Live.
That was really good. Are you going to start? Okay, Robin, that was a really good bit of astronomy, and we're very grateful for that. Thank you. And you brought us, what was it you brought us last week?
That was the Nova in Cassiopeia, which is still around. It hasn't faded at all, as far as I can tell. And so people can still look at it. It's not bright, but it's there. And you can find a chart on the SPA homepage, popastro.com.
Kath has just asked, is there something following the ISS? I thought there might have been something in front of it last week, but I don't know where the whereabouts of this battery pallet.
I didn't see it, but it may be there. Let me just show you. Well, no prizes for getting that constellation. So that's the stage of the flower.
Thank you so much, Robin. Catch you later.
Okay, bye.
Bye. That's so good. Thank you so much. Robin edits our wonderful magazine. A magazine, a mug and a magazine together. You get the plugged mug and the SPA magazine. Robin diligently edits this every 2 months. We're going to have a little leaf do this later. But if you want to get a step up in the astronomy publishing world, we need an editor for this because Robin's been doing it all his whole life. And I think he might want a break now. Okay, we're going to go to Cosmo now. Where has Cosmo been? In the solar system. This is in the solar system. So you can guess, please, popular astronomers. Now, I'm going to give you the 3 clues, but hold off from writing the answer until I've given all 3 clues to give everybody a fair chance to test their grey matter. So Cosmo, turns out he's a little hand warmer, and I microwaved him this week, and he's amazing because I get very cold hands where I live. We live in quite a cold building, and he is lovely, but he's been to somewhere a lot more extreme than the heart of my microwave. So Cosmo, where have you been? He said... Let's fix these headphones. He says, it smells of bitter almonds. What smells of bitter almonds, Cosmo? What could it be? The area that he has been, that clue doesn't make sense that you've written here for me, Cosmo, you silly little telescope sloth. Okay. Hi, Vicky. I'm a recently new member. Like the show very much. Thank you. Cosmo loves you too. Thank you very much. So he's been somewhere it smells of bitter almonds. He said there are broad regions of bright and dark terrain. These include Xanadu, a large reflective equatorial area the size of Australia. So it smells of bitter almonds. It's a large reflective area about the size of Australia called Xanadu, and there is when the radar scans it, it picks up a specular reflection indicative of a smooth mirror-like surface called Jingpo Lacus, and that is in the North Polar region. So where could we be? Answers, please. First one to get it, pop up on my screen, gets adulation from Cosmo. It smells of bitter almonds. There's a bright equatorial region called Xanadu, and there's a mirror-like surface feature called Jingpo Lacus. Where could we be? Cyanide. Cyanide, well, yeah, there is cyanide there. Where do you think Cosmo has been? Where has he been? Come on, popular astronomers. Oh, Alan was first there. We'll see if a couple of others get the answer incorrectly first. Next after Alan. The other satellite was probably a Starlink. Yeah. Wendy says Venus. What do you reckon to Venus, Cosmo? No. He's not been to Venus this week. Where could he have been? Bitter almonds, cyanide. Yeah, it's the new Mr. Kipling's flavour. Mr. Kipling's bitter almond cyanide flavour. Sorry, Mr. Kipling. You definitely don't make cyanide flavour cakes. I'm sorry, I take that back. He's not been to Jupiter, have you, Cosmo? No. Kath Elizabeth and Alan Clitheroe were the correct answers. You've been to Titan, haven't you, Cosmo? He has been. Well done. It's basically a stinking hellhole that definitely does not smell of Mr. Kipling cakes. Okay, well done, everybody. Okay, we're now going over to our first guest. Cosmo can go and sit back over there. Carolin Crawford, communicator of science and astrophysicist researcher. Carolin, we're coming to you in 3, 2, 1. Good evening.
Hello there. Let me see.
How are you this evening?
I'm good this evening. I was really enjoying that pass of the ISS you were showing just now. We've been watching it the last few nights from Cambridge, and it's been quite fantastic these, last few evenings. Very good, nice, slow, bright passes right past the moon. Exactly, yeah.
So last week we had an ISS expert on called Liam Kennedy, and he's invented this Raspberry Pi that detects when the ISS is near, and it beams the telemetry to your TV, and it lights up when the ISS is near. And he said, because he's an expat Englishman living over in America, and he said the UK is super lucky because it's at the northern extent of the ISS range, and we get some of the best passes in the whole wide world.
I can well believe that. Yeah, I can well believe that.
So whereabouts are you this evening, Carolyn?
I'm in Cambridge. So yeah, not very exotic, not as exotic as where Cosmo's been recently anyway.
I know he's also been in the microwave this week, which was very, very thrilling. And he came out, he was lovely and warm. You see, he got abandoned here one night. And when I came in to do my show, I found him, and he hangs off my telescope, and he's been abandoned. And I've had him for about maybe 6 months and never knew that he was a microwave beanie. So he now earns his keep. So what's your specialist area of interest when we don't talk other than Oumuamua, Carolyn?
Well, I don't really work on Oumuamua, but it's just one of the most fascinating things that's been discovered in the last few years. I tend to work on giant galaxies. So my own research is the largest galaxies in the universe and the black holes that lurk at their cores. But to be honest, I'm interested in all astronomy. So one of my main roles for the last few years has been as the public astronomer here at the Institute of Astronomy in Cambridge, just talking about anything to do with astronomy that I really like and enjoy. So I think it's a pretty good deal.
That sounds like amazing. Actually, not dissimilar to my gig. I just pick and choose the ones that get me excited.
Yeah, I agree.
I know we're going to chat about Oumuamua, but tell me about the giant galaxies and how big they are compared to ours.
Oh, our galaxy would be tiny in comparison. So I'm talking ones that sit right at the centers of clusters of galaxies. So they've got trillions of stars, and they're sort of up to 1 million light years wide. They're enormous structures compared to the kind of little, Milky Way that we live in. And the thing about them is that, the largest galaxies have the largest black holes at the core. So it's, you've got a supermassive black hole in a supermassive galaxy, and the interplay between the two is always very interesting. So that's the kind of thing that I like to go and look at with telescopes.
And where's our nearest giant galaxy then?
Well, the nearest really big one, of course, is M87, which has been famed for the Event Horizons Telescope. That's the one where it took that picture of the silhouette of the black hole with the Event Horizon Telescope. So that is only about 55 million light years away. So that's relatively nearby.
Wow. I didn't know much about giant galaxies, actually. So you say they've got trillions of stars in them then, and we're just like a backwater in comparison. That is amazing.
Yeah, and there is, surrounded by thousands of other galaxies, really rich clusters of galaxies. You might have thousands of galaxies all held together by their mutual gravity. And right at the center, you have this big fat galaxy that's just sort of sitting there, lurking right at the center of the gravitational potential.
Wow. Okay. Wow. Well, that's about as thrilling as it gets. But let's learn more about possibly one of the best names in the world, Oumuamua. What does Oumuamua mean, first of all?
Well, it comes from the Hawaiian language, and it means a sort of scout or a messenger, perhaps from the distant past or a distant place. And as you see, that's a very apt name for Oumuamua, because that's the role that we think it has, certainly as a sort of visitor to our solar system. But yes, it's from the Hawaiian.
Oh, and tell us a little bit more about, first of all, because I've just read here now, we've got an 8-year-old watching and screaming at the TV. So let's have a recap on what Oumuamua is, especially for 8-year-old George in swaddling coat.
Well, Oumuamua was discovered probably about 4 years ago now, in 2017. And the thing that is exciting about it is it's a chunk of ice or rock or something, but it's not originally from our solar system. So this is an interstellar tourist. This is a chunk of ice or rock, and we'll talk a bit more about what it might be, that we think has come from another planetary system, not necessarily a nearby one. It could have originated from the other side of the Milky Way, and it's been traveling through space for thousands, if not millions, if not perhaps even billions of years before it had to just sort of plunge in right through the core of our solar system, past the Earth, past the sun, and then whiz on out again. Yeah, exactly, like that.
It's like somebody throwing a boomerang from very far away, then you don't know where it came from.
Yes, except this is not a boomerang that's going back anywhere. It's, it left its solar system and it's just been traveling through the galaxy ever since. And it's certainly not going to come back to our solar system. It's traveling too fast, too furious to ever be sort of caught by the gravity of the sun. And it's just was a very fleeting visit through the core of our solar system.
So how did they ascertain that it didn't come from our solar system then?
Well, the key thing about it is, first of all, its orbit, because you have the sun at the center and then all the planets lie in a sort of flat disk around the sun. And most of the matter in the solar system is in this sort of flat disk. Well, then this thing, when they detected it and then they tracked its orbital path, they did follow-up observations with the telescopes, they tracked its path, and it's basically come in from right above, swung past the sun, and then gone out again. So it's come from a region where there isn't a lot of mass in our solar system. And I know the only thing that comes in are comets right in the edge of our solar system from the Oort cloud. They come in at that, we call it a hyperbolic orbit. So it's one of no return. So first of all, it's the orbit is strange. Okay, we only see comets in our own solar system come from that orbit, and we know it's not a comet for various reasons that I'll go into in a minute. But the other thing is it's traveling too fast. It's traveling faster than anything in our solar system. And the thing about relative to the sun and all the planets, it's traveling about 25 kilometers per second faster. So that means it can't have ever been attached to our sun. It's traveling too fast to be held by the gravity of our sun. It's just whizzing right through.
Oh, it's so good. It's so good. So what's it look like?
Well, it's very difficult to tell because when they detected it, it was already heading out of the solar system. We kind of missed its nearest pass by Earth by the time it was actually discovered. And it was traveling so fast that they could only follow it up with the biggest telescopes for the next week. And even in all those images, it just looks like a tiny point of light. So it is just, it's really clever how they determine things about it, because they know it's small. So it could be tens, at most perhaps a couple of hundred of meters wide. It's red. And it's very, very shiny. And we know it's shiny because if you watch the light from it, it varies in brightness. Okay. And that means that it's tumbling. You have something that's tumbling every 8 hours. And as it turns different faces of the object towards you, you see different brightnesses. So that gives you an idea of how shiny it is, how big it is, and also the shape it is. And when you combine all of this with modeling, we think it's something that is either a sort of long cigar shape, so a ratio, say, 10 times longer than it is wide, or perhaps a sort of flat pancake shape. So again, about sort of 5 or 6 times wider than it is. So sort of flat and thin, like your Millennium Falcon, or long and thin, like a cigar. So it's got a very weird shape that we don't see anything in our solar system look like that as well. So it's very shiny, it's very small, it's very red. But the thing that was really exciting about it was that as it left the solar system, it accelerated, right? Wow. Now, this is not just the sort of gravitational slingshot as it sort of wheels around the sun, but it is a very small, but it's still significant acceleration. Now, where we see this is if you've got a comet. Like if you've got an icy chunk of comet, we've all seen the beautiful tails that develop from comets. This is called outgassing. So when all the ice is on the surface, heat up as the comet nucleus gets near the sun, they outgas, and you get this tail of gases behind it. And because it comes out in sort of jets, it's like a little rocket. It gives a thrust and just pushes the comet. Now, you don't see that with Oumuamua. There is no dust tail. There is no gases being thrown out. They've looked at it with an infrared telescope. Absolutely no sign of any of this carbon monoxide, carbon dioxide, dust particles, anything you see from an icy chunk of rock. So it's presumably icy rocky. It's got to be, we've got a question here from Tim. How do we know what it's made of? It's got to be something pretty robust, because this is something small that is tumbling really fast in a chaotic fashion over every 8 hours, and it's held together, so it must be fairly dense, so some sort of rocky, icy material. So this it's a really weird object, and it's been in the news because nobody could really say what it was, and it's because of its weird dimensions. And one of the sort of more extreme ideas is it could be some kind of alien spacecraft, some artificial spacecraft, that's like a solar sail. Don't think that's the case. And in fact, why it's in the news again this week is quite exciting. There've been a couple of papers where they're modeling the orbit, the gases, the site. They're putting everything together, and they think it's a chunk of solid nitrogen ice. Okay,
right.
So very, very shiny. If it's made of nitrogen ice, you can boil the gas off, get that little push out of the solar system, but you don't detect it with the telescopes. You don't detect nitrogen gas coming off. And it'll be, maybe when it fell into the solar system, it was much bigger, say about 100 meters wide. But nitrogen starts boiling off at fairly low temperatures. So as it's traveled through the solar system, it's just been eroded, the gas has been given off. One of the authors of the paper, Alan Jackson, has a lovely description of, like you've got a bar of soap. Starts off nice and plump, and as you rub your hands in the bar of soap and use it, you end up with that sort of long, flat piece. That's more or less what's left of Oumuamua as it's been traveling through our solar system. Most of the nitrogen's boiled off, and you're left with this odd-sized chunk from another solar system.
An alien civilization lost their soap in the bath.
I don't think so. We actually, the fact that it's not an alien, or it doesn't fit an alien. Nobody seriously thinks it's an alien spacecraft. There's this wonderful quote from Carl Sagan that if you make an extraordinary claim like that, you need extraordinary data, and it's not the case with Oumuamua. It can be explained by this lump of nitrogen ice, but in my mind, that doesn't make it any less interesting, because what you have to think of is that this is a chunk of another solar system that has happened to come our way. So by studying objects like this, and now we know what they look like, now we know where they come from, we can start to perhaps find more of these interstellar visitors. And indeed, at the end of 2019, they found a comet, which was the second interstellar visitor to our solar system. And as soon as you get these wonderful new spacecrafts, like observatories like the Vera Rubin telescope that do these, they're much more sensitive to things that change in the sky. We should be picking up a lot more of these interstellar visitors, and from these chunks of other solar systems, they tell us something about perhaps the early phases of other solar systems, because how did it get thrown out of that solar system? Early planetary formation is a violent and messy place, and it could be that these get thrown off another solar system being formed and at great speed and end up going through ours. So it's great. We just sit here, and as we begin to get sample sizes of these, we learn more about other solar systems. Now, very good question here from Vernon. If it is nitrogen, why is it red? A very good question. It's very shiny. And if you think about this, imagine, for example, we've all seen the beautiful pictures of Pluto, where it has this wonderful heart, the Sputnik Platea, or whatever it's called, which is really shiny. That is solid nitrogen ice, very reflective. But if you see other regions on Pluto, they're quite red, and it's sort of an organic substance called tholins. And one of the things that happens as it comes through the solar system, it gets irradiated by cosmic rays from our sun, and there's a sort of interaction between those and the nitrogen, and maybe there's a tiny bit of some kind of maybe there's a tiny bit of methane ice or something mixed in. And one of the things, if you have these kind of icy bodies exposed to a lot of radiation, they do get this sort of red smattering on the surface. So again, just think of perhaps the surface of Pluto as a comparison.
Oh, thank you so much. Okay, we'll take one more question. Let's have a look. Do we have good resolution spectrum?
In the infrared, we have a fairly good. Oh, hi, Jack. Yeah, we have infrared spectra. We don't. The thing about the spectrum, to be blunt, is you can have a good resolution spectrum, but if it doesn't show any features, it doesn't do you much good. That's how we know it's red, from the spectrum, from the colours, but it doesn't actually show any features. We don't see these molecules being outgassed, so we're not getting emission lines from them. So what do I think about the idea of come from? It might have come from alien civilizations. This from Jan. I don't think we need to appeal to alien civilizations. It's a nice flight of fancy, but I don't think we need it. And the thing you have to remember is that this is just the first of these we've seen. We saw a second cometary thing 2 years later. And my prediction, for what it's worth, is, come perhaps in a year's time, via a Rubin Observatory and other robotic telescopes and detection systems start observing automatically the night sky all the time, we're going to detect whole populations of these interstellar objects. These are just the first two that we've seen. I think there are going to be a lot more, and that makes it a lot less likely that it's anything to do with alien civilizations. And certainly, astronomers expected these. They've been predicted, these chunks from the early formation processes in other solar systems, perhaps ricocheting through the universe. This is just the first time we've identified them.
Well, I hope that the second one that's detected will be called Oumuamua Tua.
Oh, well, it's no, the second one detected is Comet I forget the number, but it's Comet Borisov. So that is actually a comet.
Of course, yeah.
So it's much more like a comet. It's Oumuamua that's particularly strange, or had been particularly strange, except everything kind of fits this picture of a 40-meter wide slab of pure nitrogen ice. Perhaps there's smattering of the red tholins on the top.
Oh, wow. Thank you so much. Everybody's loving you this evening. Carolyn, thank you so much for coming on Pop Astro Live this evening. And be sure to share the video. We've had a great time with you.
No, that's great. And I'll just say in the comments, lovely to see this reference from David Graham about Northumberland Telescope, which is, of course, at where I work at the Institute of Astronomy. And, this is one that I have used both as a student and we use for our public outreach evenings and Wednesdays during the winter season. So if anybody's near Cambridge, you've just missed it, but next winter, come along to the public outreach and have a look through the Northumberland Telescope.
I think, is that one of the ones in the dome?
It is one in a dome, and it dates from I've forgotten now, 1838. So it's a lovely, gigantic Victorian refractor.
Oh yes, I took some 3D pictures in there. It's beautiful.
It's well worth seeing. Yes, so lovely to see the name drop for that.
The name drop. Thank you so much. Thank you. Everybody is saying thank you so much. Thank you, Bob. Thank you for your thanks to Carolyn. See you later. Bye.
Okay, thanks, Vicky. Bye, everyone.
Bye. So I'm sat here with the moon and I'm just realizing I look like a very an aerobics fortune teller, like aerobics with my crystal ball here, which is actually the moon. I'm going to look into the future now and tell you that in about 5 minutes we're going to have Eleni, maybe a bit less than that. Then we have got our third guest, and then we have got Sonia with the reason for the seasons. Now, do you remember last week when I got really spooked in here and I heard now, so if you're new to the show, I live on a holiday park. I have to come down to the stables / laundrette to do the show. They're old buildings and we're Wales hasn't opened up yet. Tomorrow, I think we open up to Wales within Wales. Why didn't they use that on the publicity? Wales within Wales, wheels within wheels. So I think we'll be able to travel around internally within Wales. But last week, as I was playing the video that I'm about to play now, I heard a big, deep male booming voice, and I nearly needed to use the washing machines after it. It was so scary because the voice was so booming and distant and like unexpected. Well, you'd never guess who it was. It was actually not a prowler. It was not a person outside. It was not my imagination. It was real. And it was Lord Rees, the Astronomer Royal. I always want to say Royale, but that's a Royale with cheese, isn't it? Now, I'm going to play this video, and at 50 seconds, because I edited the video, there's a clip of him doing a seminar, and I forgot to turn the audio down on his voice, and you will hear him for maybe a half a second, rah, 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 like that. It's no wonder I was so scared. So look, this is a new SPA's new publicity video. It's on our website, and you will recognize many amazing people on this video. So do you want to have a little peep of it? It's great.
When I first started being interested in astronomy, it was just a question of looking up at the night sky, and it is spectacular even if you don't know what you're looking at. But at some point, very quickly, you decide that you want to know more, and the more you know, the more wonderful it gets. SPA has been helping people into astronomy to understand what they're looking at for more than 50 years.
As Brian says, the SPA is a great way to start or accelerate your astronomical adventure. We spoke to our new president, Professor Andrew Coates. Why should people join the SPA?
Well, the SPA is really important to join. We have, it's probably the best society for entry-level astronomers in the UK. And the SPA gives you so many benefits. There's, of course, the magazine. It's great for young stargazers. My colleague Lucy is the chief stargazer.
We have a packed section for the junior stargazer.
I'm Lucy Green, I'm Chief Stargazer, and it's my role to help you all enjoy the fun of astronomy.
If you want to make new astro friends, our interactive chat show is the ideal place.
Then you just float, and it's like that feeling when you're just floating in a pool.
There are so many reasons to join the SPA. What will yours be?
Strongly recommend, if you want to learn a bit more, you join the SPA or go to the website popastro.com.
So yeah, 50 seconds into that, there's a blah, 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 and it was Lord Martin Rees, the Astronomer Royal, terrifying me and several other of our viewers who were quite concerned as well that we had an Anglesey Prowler, but can't believe it. It was the Astronomer Royal. Hilarious. Right, okay. We are now going to go over to Eleni, who's been waiting patiently in the green room. It was was it a walrus? I have one of those moons. I saw it in the shop discounted to 50p as the box was damaged. Yeah, this is the battery version. The batteries last a couple of weeks depending on how much you have it on. But I would much rather have had the... it's not showing up very well, is it? The USB version. Okay, we're going to go to Eleni now. Coming to you in 3, 2, 1. Hi.
Hi, everyone. Good evening. How is everybody doing?
Oh, thank you. We're all doing really well. All the better for seeing you. And you're about to hit us with some amazing astronomy news, aren't you?
I will try to do my best.
Oh, how are you, Eleni?
Promise. I'm good. I'm all right. A little bit tired. So if when I get tired, my accent becomes even worse than what it is at the moment. So bear with me. It's only 10 minutes. And then you will get back to listening to normal.
Oh, no, we love your accent.
So apologies for that.
Eleni, now, sometimes when I'm just stalking you on Facebook, I see that you do headstands and yoga.
That's true.
Do you think one night you could read out your whole report from doing upside down on your head?
You know what? If I make it short and succinct, I think I can.
Right, next week we want you upside down. That would be amazing.
Okay, I'll try. I'll have a wall behind me just in case.
That is fine. You can cheat with the wall. Right, okay, so we'll cut over to you then. Wendy says, lovely to see you again. You have a beautiful accent. We love your accent.
Very much. Thank you. I just know it becomes really Greek after a certain level of tiredness is reached.
Okay, so let me have a fiddle round in on the screen
slide. Yeah, I'll make it. I'll put it on a slideshow.
There she is, and I'll go away now. Okay.
Right. Okay. Can everybody hear me? All right? Because I can't hear you, but I will assume that everything is going okay. So I've got a few things to talk about today, like a couple of things that are quite big and then a couple of smaller things that are good news. The first piece that I'm bringing to you is an answer to why Mars lost its water. Okay, so we know that it used to have a lot of water, but it wasn't exactly known how it lost most of it. So how do you go from a very aqueous environment to a completely desert-like planet? So that's been a big question. And it turns out that vaguely there was this idea that, yeah, it has been leaking water from its atmosphere for a long time, but now new studies give us an insight as to how this might be happening. And the answer to that is kind of a dual nature. So partly it's down to the fact that when the Martian orbit takes the planet too close to the sun, the atmosphere warms up. And what happens is that all the water vapor that's been kept below a certain altitude starts to rise up. And as it rises, it actually saturates the atmosphere with water. And this results in the water to actually escape to space. Add to that the help of dust storms, okay? And what happens is that they make this phenomenon even more prominent. So they help the atmosphere to warm up even more. And so they create a very efficient mechanism to lose or leak water into space. And that's what's happened to Mars, most likely. And it's now a desert-like planet. And I could not resist putting a picture of Mars from Perseverance. So you'll see, whenever I talk about Mars from now on, it will always be with a picture from Perseverance. So moving on then from Mars to something a little bit different. There we go. So I don't usually talk about potential missions, but I think this one is worth mentioning. So this mission is named Pandora, and it was selected by NASA for further concept development. And I want to mention it because I think it's really, really cool, and what they have in mind and what they're trying to achieve with this mission, if it goes through, will be spectacular. So the idea behind it is that you basically are going to look at specifically about 20 stars or so and their planets, and focusing on this relatively small sample, do some really high precision measurements on their atmospheres. So this means that we are going to have, if it goes forward, a very comprehensive high precision sample of exoplanetary atmospheres. And I think that's amazing, like the concept is amazing. So the plan is for Pandora to observe these planets and their host stars in both the visible and the infrared wavelengths simultaneously. And this will allow for fluctuations that happen in the star's sunspot cycle to actually be properly documented, and their effects on the atmospheres of their planets to also be documented. And if this whole project goes forward, I think that it's going to offer some amazing data and insights on exploring and understanding alien environments. So fingers crossed that it actually moves forward. So now getting on to my final bit on space news and weather, we do have an aurora alert. So most weeks we have one. So there is a very strong chance of a geomagnetic storm on the 28th of March, this Sunday. And all high latitude sky watchers, amateur astronomers, amateur photographers, or just lovers of auroras and the night sky should just be ready for a potential aurora. And if you do, take a picture and post it on Facebook under our video as well, so we can see. It will be nice. I think if people start doing this, it will be so nice, because I'll feel like, yay, I'm saying something and they're going and taking pictures.
Oh, that's nice.
And I will leave you with some really good news, I think. Okay, so we all remember Apophis, or I hope we do. It's a ginormous asteroid, 350 meters long. And it was first observed in 2004, and it kind of, made scientists a little bit worried, because the observations predicted quite a few impacts for 2029, 2036, and 2068. And something so big, we're looking at kind of extinction level impacts, very bad stuff. Thankfully, latest observations ruled out these collisions, that there is no any probability for collisions now, for definitely not for 2029, 2036, and most likely not for 2068. So I'm really happy to hear that. I don't know about you, because I plan to be alive in all these.
Thank God. Thank God.
Yes.
Thank God, yeah. Do you know, actually, because the threat of asteroid always seems so distant. And then when it said that maybe it could be in 2029, I genuinely felt really scared then.
I know, right? It's just too close. I've got, there's so much to do. I can't just, we can't just go away so soon.
There is so much to do. Oh my
I was
God.
very, very relieved when, I read that, and ESA is planning to remove it from the risk list, which is amazing.
Hooray for that!
This is me, and these are my news. I hope people enjoyed them.
We loved it. Thank you, and hopefully next week, at least do some of your report upside down.
I will try. That will be a great challenge for me. And you know what? If I can do it, if I can do an astronomy report upside down, then I've definitely reached a different public engagement level. I'll be somewhere up there.
Yeah, I'd definitely like to see Chris Lintop do that. We've got the upside down space news.
It's gonna be fun.
Okay, thank you. Have a beautiful weekend.
You too. Bye, everyone.
Bye. Yeah, great. Eleni's going to be practicing her headstands, and we will be the only astronomy show that has got an upside down news reporter. So, okay, Cosmo has been off wheeling himself around the solar system. He's got another guessing game for you. So, what Cosmo does is he whispers in my ear, he controls me and tells me to do things. And also, he goes to amazing places in the solar system and reports back. So if you've not played the game with Cosmo, what you have to do is wait until I've read out the 3 clues. Don't try to guess before, otherwise it stops people from taxing their brains. Even if you know the answer, just hold back. Whoa there, Nelly. Hold back and wait until I've dished out all 3 of the clues. So Cosmo has been to quite an amazing place. Well, of course, he's always going to go to amazing places, isn't he? Where's the first place that he went to? Okay, it's in the solar system. That's the first clue. Okay, it's about 5,400 Kelvin, which is only a few hundred less than the surface of the sun. Oh, look, his little head wobbles. So it's 5,400 Kelvin, which completely staggers me because the surface of the sun is only a few hundred degrees hotter. Okay, this area, this place has got a mass about 1.2 of that of the Earth. So, thank you. No, 2 items of good news. Eleni reporting upside down, and no extinction event. Cosmo's happy with that. What's that? You've been to an asteroid and changed the course of it. Be careful, Cosmo. Don't meddle with stuff like that. The third clue. It's mainly composed of iron, nickel, and silicates. Okay. Here's all three of the clues. It's about 4,500 Kelvin, which staggers me because that is only a couple of hundred less than the surface of the sun. It has a mass at about 1.2 of the Earth, and it's mainly composed of iron, nickel, and silicates. Where could it be? Sylvius, well done. It's not Venus, though. Where could it be? I'm going to give you a clue. No, I've just given you 3 clues. You don't need any more. Where could it be? It's a real obscure place, this is. It's red hot. It's grim, it's heavy, and it's mainly iron, nickel, and silicates. Where could it be? People are saying Venus. Well done, Kathy. You're always guessing. I do like you're a very good sport on these things. Cosmos says no. Oh, but which core? But which core? The center of the Earth. Ian Baker. I'm afraid Cosmos says that's wrong. Where could it be? Where could it be? You're getting close. Mercury. That's actually a really good guess, and it's not Mercury, I'm afraid. It's not Mercury. The sun facing side of Mercury, I'm sorry, it's not Mercury, everybody. It's a lot more obscure than that. You might want to keep on guessing while we introduce Mark Sephton, our second main guest that we've got on. Let's have a look. The core of Mercury, close but no cigar. An ancient planet within the Earth? No. Good guess though, David. Jupiter, as they called it when I lived in Ibiza. Jupiter. Comet, Sylvius Weir? I'm afraid it's not. No. Oh, Io. No, I believe Io is very cold, but this is red hot. It's redders in this place. Proxima Centauri. No, Catherine, it is within our solar system. Okay, you lot keep guessing. We're now going to go over to Mark Sephton. Colin Carter is getting close, but Cosmo says no cigar, not for Colin. The answers are going too quick. The moon's core. No, Peter, I'm afraid it's not the moon's core. Keep on guessing. Come on. The center of one of our gas giants. How hot are they? It is solar. It's within our solar system. Center of the sun, a volcano. Right, we're going to go over to Mark Sephton. Oh, I've got you flummoxed this time. 3, 2, 1, Mark, you're on. Hi, Mark.
Hi, Vicky.
Hey, do you want to have a guess as where Cosmo's been to?
Oh, no, I don't want to spoil the fun.
But do you think you might know, though?
Well, like I say, I don't want to spoil the fun. So let's keep it going.
Thank you, Mark. That's so good. It's people are saying the core of Jupiter, but it ain't the core of Jupiter. Okay, now you have got one of the most impressive job titles I've ever come across: Professor of Organic Geochemistry and Astrobiologist, and a member of the Mars 2020 Rover Science Team.
I'm very lucky.
That is cool. Tell us a little bit more about what all this amazing job description entails, then, and whereabouts are you this evening?
So I'm in northwest London, Ruislip. I work at Imperial College, so I commute into South Kensington, where I used to do most of my work, of course. These days, it's done remotely. And I'm an organic geochemist, which effectively is I'm like a forensic detective. I use organic signatures to tell us about the history of the Earth and the environments of the Earth. Reconstruction of past ecosystems and past life and what's happened to the records, and of course that's very useful for looking for life on other planets. So if I can recognize the fingerprints of life on Earth, I can recognize the fingerprints of life on other planets, or even the chemical evolution that preceded life, such as we see in asteroids. So it's a little bit like crime scene investigates, but in a solar system context.
Oh, actually, can I just link you back? I'm just going to jump back a few questions, actually. You revealed, we chatted earlier today, and you mentioned Oumuamua and about how there's some surprising fingerprints of interstellar activity in our meteorites. Now, that just blew me away, made me want to dig out my meteorite collection and bundle it.
Yeah. Don't do that if you're interested in organic analysis. That'll cause all sorts of problems. We'll pick up your fingerprints on the meteorites. But that's true. So meteorites are effectively a builder's rubble left over from the formation of the solar system. And the solar system was formed from a rotating disk of dust and gas that came from interstellar clouds. And so there are these remnant signals of our interstellar heritage, and they're discovered in some of the atomic level chemistry in the meteorites, and particularly dramatically in interstellar grains, pre-solar grains. And these can be diamonds, silicon carbide, and graphite, and they're reflective of processes that predate the solar system. So they have the signatures of stars that are beyond ours, and they clearly can't have been generated within our solar system. So again, the chemical fingerprints of beyond 4.6 billion years in these rocks that fall on the Earth.
Oh my gosh! And do all meteorites have these in?
So some of the meteorites have, the Earth came from the same material as the meteorites, but the problem with the Earth is it's got a rock cycle, and it's like you've thrown your forensic materials into the washing machine and washed away all the evidence. But the best meteorites, the meteorites that have the strongest signals of the early solar system and before, are the ones that have been processed the least. So the carbonaceous chondrites, which are really primitive, they have the similar elemental composition to the sun, and there really are these hardly touched, hardly processed remnants of billions of years ago. So they're the best records, the ones that have been. It's just like a crime scene. If people have been inside your crime scene and moved things around, then you lose your record. But if it's pristine and no one's touched it, then your crime scene is perfect. And some of these carbon-rich asteroids are perfect recorders of the early solar system and beyond.
So this new one that's hit the driveway is it Cheltenham? How is that looking for fingerprinting?
Yeah, that looks good. It's a carbon-rich meteorite. It looks like a carbonaceous chondrite. Some of these very, very primitive meteorites. And, we're analyzing it currently in our UK laboratories. So it's fascinating to have the secrets of the solar system, or the answers to the secrets of the solar system, just drop literally in your lap. And with all of our wonderful laboratories ready to analyze this sample and uncover the secrets of the solar system. It's going to be an exciting few weeks as we get to grips with the chemistry of these materials.
Ooh, exciting. Okay, now let's jump across the solar system to Mars. Why Mars?
Well, it's our sister planet. When we look at Mars, we see evidence of liquid water, and that raises the possibility of life. We're really looking for these forensic records of past life. And to have past life, you need to have habitable conditions. And that means the presence of water, the presence of an energy source, the raw materials of life, and then you need to have the right duration. And Mars, in its early history, seems to have that, very special recipe of life. And around that time, there was life originating on Earth. So why not on Mars? If the conditions were similar, and they were there for long enough, then why did life originate on Earth and not on Mars? And that's the question we're going to answer. Did life originate on Mars? And do we have these forensic records in these old rocks in Jezero crater that will tell us that we're not alone, or we've not always been alone in the solar system when it comes to life?
Oh yes, you've got a little bit of a video clip to play. Should we go to that?
I have, yeah. So this gives a flavour of how the conditions on Mars may have been similar to the conditions on the Earth. Here we go. So we can see we're now 4 billion years ago, and Mars still had a thick atmosphere and water on the surface, not too dissimilar to how we think that the Earth might have been at the same time. This was before Mars lost its magnetic field and started to lose its atmosphere. And of course, once we started to lose the atmosphere and the magnetic field, the planet was unprotected, and radiation could bathe the surface with potentially damaging radiation that can harm life. When you lose the atmosphere, things dry out, and the Tharsis volcanoes at this time were booming away and producing sulfurous gases, and they acidified the environment. So we have these called sulfate deposits being generated at the time. And then eventually you've got this very thin atmosphere, and with a thin atmosphere, things dry out, and we have the iron oxide rich conditions that we see at the present day. So just because conditions on Mars are red and dry and oxidized at the moment doesn't mean that it was that way all through Mars's history. And so it's for this reason we're interested in the very old rocks, because that's when we think that life might have originated on Mars and left a record in the rocks. And we send satellites to look down on the planets, and we send landers and rovers. And we've currently got a rover that's going to look for samples of organic matter and the minerals that are normally associated with organic matter. And we're going to prioritize and select those samples and bring them back to Earth. Sorry, I can't hear.
Sorry, had my mute button on. I was chatting with Cosmo. So we have got a battle of locations going on in the chat room. People are trying to guess where Cosmo's been, but they also want to know where your accent is from. Personally, I think you've got a bit of twang like Tim from from Jodrell Bank. I can't remember his surname now. Somewhere up in Bolton, Burnley way.
Yeah, I'm from the northwest. Used to be a much stronger accent in the past. I'm from Merseyside, Lancashire border.
Oh, so whereabouts would that be then?
St Helens.
Oh,
so
okay.
In between Liverpool and Manchester.
Oh, very good. Well, you've got rid of your St. I know what the St Helens accent is like, having got a lot of family from there. So, yeah.
Okay. Believe me, it takes, when I go home, it takes 2 minutes and it's completely back.
I'm going down the town to get my hair permed.
Absolutely, yeah. Yeah, that sounds good.
They call me Victoria.
Yeah. I feel at home already.
Oh, thank you very much. We like to make people feel welcome on Pop Astro Live. So you are involved in a pretty spectacular Mars mission. Tell us about it. What's the name of the mission?
So it's Mars 2020. So that was the year that the mission was launched, and it's the Perseverance rover with the Ingenuity helicopter. And so we're flying helicopters on Mars these days. It's pretty exciting. Science fiction becoming science fact. And we're what's new about this mission is that we're actually going to collect samples and bring them back. It's the first step in Mars sample return, and to this. So far, what we've done is we've sent a small amount of instrumentation to Mars and looked at the large amount of rock in front of us and tried to analyze a few pieces. And now we're going to flip that. We're going to bring back a relatively small amount of sample, about half a kilogram, in a sort of grapefruit type size container, and then we're going to have all of the Earth's wonderful, sophisticated instrumentation to really interrogate these samples and try and understand their history and see if there's evidence of, or just a glimpse or a tantalizing wisp of evidence of past life on Mars. And of course, the philosophical impact of evidence of life on another planet would be a real step change in our understanding of our place in the universe.
That's pretty impressive. So tell us about the sample return and how it's working then.
So what we do is we're there at the moment, and we're gonna drill some samples, a selection of samples, and we're going to cache them on the surface, and then we send another 2 spacecraft, probably early 2030s, and one will be a fetch rover that will pick up the samples and bring them back to an ascent vehicle. And then the ascent vehicle will join with a satellite and be sent back to Earth. So a whole program or campaign involving 3 launches and 3 spacecraft, which will bring samples back to the Earth. And if you think about what happened with Apollo when we brought samples of the moon back, and we're still analyzing them, 50 years later to the present day, and discovering wonderful things about the history of the moon, then similar things could happen with these samples from Mars. So maybe the younger people listening to this broadcast will be the people who analyze those samples in the 2030s and maybe uncover some of the most dramatic or answer the most dramatic questions in the solar system, like, was there life on Mars? How did Mars evolve? What is the geological history of Mars? So there's a real sense of excitement around this mission, to actually go and choose your samples and bring them back, and then interrogate them with, these very sophisticated and powerful instruments we have on our planet.
So, wow. Okay. Yeah. So you mentioned that people today, maybe some of the youngsters, might be analyzing Mars samples. What career path would they have to take to get their hands on a piece of Mars?
So this is, that's a really interesting question. And people ask me, how do I get into the space business? And it's just like any other business. There's lots of opportunities, but you've got to be able to add value. You've got to have a skill. So I'm a geologist. I was initially trained as a geologist. I went into the organic records in rocks, and then that made me valuable for people who were interested in detecting life on other planets. So it's all about developing skills, and we have engineers, we have there's space law, there's a whole range of skills that make you valuable to the space industry and the space business.
Yes, and so one of the areas that I work in is encouraging people into the space sector, and I use video propaganda to do that, because there's so much opportunity. There's a huge skills gap, especially females. I think it's about 16% female, and literally your day job can usually be transferred over into the space sector. I think there's so much opportunity, and the massive investment going on. There's just millions of pounds coming from the government funneling into the space sector. What an up and coming sector it is at the minute, Mark.
Yeah. So it's every big effort, every big exploration expedition, which is sort of what these things are, involve teams, and teams need all the skills. And so if you have a valuable skill for any activity, you can direct that towards the space business. So it's about developing that your unique selling point. It's about developing your education and developing your skills and being a valuable team member. And then you can either go into the space business or you can go into anything you like. But what you are almost guaranteed of is having a fulfilling and rewarding career, where you get up in the morning and think, today I'm going to discover something wonderful, or I could discover something wonderful. And it's for a lot of academics and people in the space business, it's that, just being one tube drive away potentially from a major discovery that gets us out of bed in the morning and gets us into work.
That's a really nice way of putting it. Right. Okay. We've got some in amongst the carnage in the chat room, people trying to guess where the toy sloth has been. There's some actually quite bright questions coming up. Catherine says, do you think that photosynthetic bacteria could have oxidized the iron on Mars?
So the oxidation is because of photochemistry on the surface. Photosynthetic bacteria. So photosynthesis came a little bit later than the origin of life. It was an adaptation, but you're sort of, you're on the right lines with bacteria in that the life we would detect on Mars would be microbes, similar to bacteria or archaea that we have on Earth. So, but it's a different mechanism for the oxidation of the surface, and you're very good. You make a very good geologist or Earth system scientist, because that's how we've oxidized the Earth's surface, by having photosynthetic bacteria produce oxygen, but then having the carbon buried. And for every carbon atom that goes into the geosphere, an oxygen molecule is left behind in the atmosphere. So that's certainly what's happened to the Earth, but it's a different mechanism on the surface of Mars. But nice try.
Nice try, but sorry, no Mars cigar. Vernon Alexander says, do you anticipate finding evidence of multicellular life?
No, so multicellular life was actually quite late in the game when it comes to the evolution of life. So we had archaea and bacteria, and then eventually they combined to form a multicellular organism. That was only about 600 million years ago. So on Mars, we're looking at rocks that are 3.5 billion years in age, and maybe a little bit older. And at that point, there was life on Earth. So we have evidence in the rocks of life at around 3.8, and certainly by 3.5. And multicellular life sort of came later. Oh well, there's debate about the time when they originated. I think it's about, actually the molecules indicate around 2.5 or 2.7. So I think we on Mars, the habitability conditions won't have got there by the time that the conditions had deteriorated. So yeah, multicellular life, its evolution on Earth would postdate the degradation in habitable conditions on the Earth. Sorry, when I said 600 million years, I was thinking about the Burgess Shale, where you have these wonderful animals preserved in the shales. But no, I think we just missed that window of opportunity. But who knows? It'd be nice to be pleasantly surprised.
Wow, how old are the Burgess Shales?
It's about I can't remember the exact date, but it's late 500, 600 million years.
So it's really hard to get into your head how long these timescales are in epochs. But Anglesey, I don't know whether you know much about Anglesey, but it's famous for its very ancient and warped geology. And they say that our rocks here are about 500 million to 600 or 700. And when I first arrived here 7 years ago, I was like, great, fossils. And it turns out there's no blimmin' fossils because the rocks are so old.
There's a reason why that people thought that Precambrian was life-free for so long. It's that, yeah, the rocks are not great for fossils. So any preservation situation is what we call Largstat, and it's a chance encounter. And life is very active on our planet at the present day, but only under certain conditions do we get preservation or fossilization. So it's about hitting a sweet spot in burial to transfer surface life to subsurface fossils, but you keep looking and you use your knowledge of preservation conditions to try and find the right rocks. And so Anglesey, it's been messed around a little bit in its history because the Earth has a rock cycle. On Mars, there's been less deformation and heating of the rocks. So we've got better ancient records on Mars than we have on Earth, believe it or not.
Oh, wow. Okay. Right then. Now here's okay. We're going to go one last question. Wow. Okay. Oh, that is a toss up between Tim and Alan. Choose a name, Tim or Alan.
Let's go alphabetic. Let's say Alan.
Alan, okay. If you had a choice of where to look on Mars, where might be the best place to find extremophile bacteria analogues?
Perfect question. That's my career. Identifying the right spots for the right records. So extremophiles are organisms that live in very difficult conditions, and part of the appreciation that life may have greater probability of existing on Mars is that we found samples of bacteria and archaea on Earth in increasingly difficult environments, high and low pH, high temperature, salt rich, desiccated, all of these conditions. But so early Mars may have had similar types of organisms, but where would you look to find evidence of that? Well, you'd use the well-known processes of preservation on Earth to get the best records. And the majority of organic matter, the molecular fingerprints of life on the Earth, of microbial remains, is in 6 big depositional events that produce these source rocks that have really generated the majority of Earth's petroleum. And it's the combination of clays and organic matter and oxygen poor conditions that have led to those thick organic depositions. And in Jezero, what we have is a catchment with water flowing into a basin, a lake, and then you've got clay minerals being deposited distal from the entrance. And of course, on Earth, it's in those distal, far-reaching clay deposits that organic matter also settles. So clays are like flypaper for organic matter. The organic matter sticks to the surface, and it's what we call clays and organic matter have what we call a hydrodynamic equivalent behavior. They behave the same way in water. So when from our satellite observations, if we can see clays, we think, that's the really best place to look for organic matter as well, because we know they behave in the same fashion.
I think that might be one of the best questions and best answers that we have had on the whole show. Mark, it's been an absolute pleasure. And finally, you've got a famous asteroid twin, haven't you?
Yeah. So if you do impress the Astronomical Union, then they honor you by naming an asteroid after you. And I do have my own asteroid 7552 Sephton. But I'm currently looking into real estate opportunities to see. Funny enough, you mentioned real estate. I nearly forgot to ask you the question. I don't know how much your house is worth. I'm going to say it's going to be worth quite a bit. Your house value, your car, all of your possessions, everything that you own. Bet against, are they going to find life or not? You walk away a naked man if you get this wrong, with nothing. You have to start your whole life from scratch. That is the scenario. Yeah. Well, the job of a scientist is to answer questions, not to bet on the outcome. Well, I don't mind what the answer is, as long as I get an answer, and that's my career as a scientist. So I wouldn't put too much emphasis on betting or wishing for a particular outcome, because it's just the truth and the knowledge that I'm searching for.
That is such a shame, because William Hill have given me fantastic odds for this bet, and now all bets are off. So I'll have to tear up my betting slip, and you can keep your house. Well done, you.
Thank you.
Thank you. It's been a really amazing show. Thank you so much. Very interesting, Bob says. Yes, very, very, very good. Very good. Okay, we're going to go now. Mark, thank you so much. And thank you so much for agreeing to come on the show. And that incredibly highbrow talk. That was a very highbrow talk. All right.
Pleasure. Thank you.
See you later. Bye. It was the perfect answer, wasn't it? Alan, it was an amazing question. You can come again. Thank you, Alan, and ask questions like that. Thank you very much. Tim, sorry we didn't ask your question. I'm sorry. Okay. We're going to go back to where Cosmo's been. I don't know whether any got it right. Thank Jerry. Mark, what a great session. Thank you so much for the clear information and answers. Jerry, sending all my love to you. I hope you're okay. Mwah. I know we chatted a couple of months ago, and I hope your situation is vastly improved, and things are looking awesome for you, my darling. Thank you, Rob Dawes. Great show. We're not going to go just yet. We've still got Sonia. And where has Cosmo been? Where's it gone? Come on, Cosmo. Where has it been? You should be telling me this now. So Cosmo has been somewhere where it's 5,400 Kelvin, which amazes me. It has a mass that is 1.2 of the Earth, mainly composed of iron, nickel, and silicates. He has been to the core of Neptune. I can't believe, and neither can Cosmo, that the core of Neptune is almost as hot as the surface of the sun. That is cray, isn't it? Okay, so thank you very much to Mark there. Thank you to everybody who guessed. I guess someone got it right in the chat room. Now then, I am dissatisfied with a large proportion of the audience. It says here that 80 people are watching. Now, I always ask every single week for you to share the video, yet we only get about 10 shares. So please, It really helps us out. We're a voluntary society, and it helps with our algorithms and helps this video proliferate. It helps us, and also it helps people who might just stumble across it to expand their astronomical knowledge. So whether you're watching this on Facebook, Twitter, YouTube, hit the share button, hit the subscribe button, help our social feeds to be elevated. It's really, really important for us to get these viewing figures up, because I drag myself down to a deserted laundrette with many armfuls of equipment down here, and I know lots of other people put loads of effort in, and it would be great if you could reciprocate by just sharing the video. Please do it. Cosmo says share. Right, we're going over to Sonia shared. Thank you very much, Vernon. And here comes Sonia. Hello.
Hi.
You've been sat there for ages.
I know. I've been listening to that. We've got a really heavy hail shower going across now, and I've just been sat here just listening to that. I'm like, oh no, background noise.
How is the hailstone today? Hail's quite impressive, isn't it?
It is. It's really coming down outside now. We had it at work this morning. I was like, oh, that's quite impressive, because there were quite decent sized hail as well coming down. So now I'm like listening to it at night. I'm like, oh God, no, not again.
Oh, so Sonia, you're one of our new members, and you are obsessed with the weather. So what are you going to do for us first this evening?
So I've got Meteor the monkey is back. Meteor, hello. And I thought, as she mentioned, the USB moon. We have a USB moon.
Oh, is it good quality? Because to be fair, the printing on this is absolutely bobbins.
If I switch the lights off. There we go.
Oh, I think you should do your whole report using that, unless you can't see your computer.
And then it changes colour as well, and it goes to that colour.
They're good, aren't they? They are really lovely. They look amazing on photographs. Absolutely brilliant photograph props. We'll have to get some in the SPA shop. Kath, our merchandise manager. As it happens, I've got my little, because I microwaved Cosmo this week, and this is usually his necklace. It's a sundown necklace. Have you seen these, Sonia?
I looked on the SPA website the other day, because I ordered a mug. I'm going to hopefully plug the mug next week on my tour.
I have actually got Wendy Taylor's picture of her mug, but it disappeared off my Facebook. I'll have to show it next week. So you can plug the mug as well. So
I shall plug the mug next week. Yes.
Which mug did you go for, Sonia?
I think it was the one with the blue sky and the silhouettes of people.
Oh, it's lovely. The SPA logo.
I really liked that one.
Brendan's just saying, brilliant show, thank you, loved it, looking forward to the next one. Are you covering Good Friday? Could be an Easter extravaganza. Oh, how can we relate astronomy to Easter? Answers in the comments, please. And I'll try to Easterify it, and I will eat Easter egg live on air. Easter egg. So Sonia, what are you doing this week then?
I'm so excited for this week, because I sent you the presentation like a few days earlier, and then poor Peter, he works from home, so he has a nice tidy desk, and when I come home on a Friday, I literally mess it up with all my notes and his computer everywhere. So I always research, and I was researching a bit. I was like, oh, that's really interesting, because when I go through and talk about especially the first bit of the years, there's about 3 other years apart from the leap year that I never even knew existed. So I was like, that is really exciting, and I shall talk about that. I was like, oh, my days, yes.
Oh, go on then, offer it. Eccentric orbits. Thank you, Verna.
So if we start on the presentation, Vicky, and then I've always wanted to say this. Next slide, please.
Oh, right, yeah, we're really going up in the world. Okay, share. Let's have a look. Hopefully, hang on. So view, present. How's that? Can we see that?
There we go. That is fine. So there we go. We are going to talk how we get the seasons and the reasons behind the seasons. But first, we'll start with the simple stuff of what are the days and what are the years. So next slide, please. I always wanted to do that.
There we go.
So the days and years. So we know a day lasts at least 24 hours because of how the Earth's orb spins on its axis around the sun. However, when we go into the years, we have the what's called a sidereal year. I didn't know this existed, and that is what it's called of how when the Earth completes an actual orbit around the sun, which is 365.2564 days, and that's what's called a sidereal year. We then have a tropical year, which comes in along with the sidereal year. So the tropical year starts from vernal equinox to vernal equinox. So that goes from spring to spring. So if you think we have the tropical year, that starts from when it goes around the orbit. So that's like January, December, if we think about that. And then we have a tropical year, what comes along and interferes, that starts from spring and it goes to following spring from vernal equinox to vernal equinox. So I'm going to have to read this because I was like, wow about this. So during that year, however, the precession moves the location spring a little ways along the orbit. So this is when we come to the tropical year. Now, the precession is, if you think about the Earth, it's like a wibbly wobbly spinny top of when it orbits the sun. And this is caused by the gravitation between the sun and the Earth. So exactly, Vicky, if you just want to do that again, that was really good. So you think about that, what Vicky's doing, that's the precession, and that's the gravitation between the Earth and the sun that causes that, and it causes the bulges at the equator, and it affects the rotation of the Earth. And so the tropical year, it's like 365.2422 days. And the crossing point on the celestial sphere between the ecliptic and the celestial equator, the vernal equinox, shifts about 2,606 of the way around the sky each year. So are we with this so far? And so this is the shift, is the difference between the tropical and the sidereal year. And then the crossing point lies in the zodiac constellation of Pisces. And then it crosses the former constellation boundary into Aquarius around the year 2600. So we then come on to a common year. So a common year is 365 days, but we have a quarter day short each year of a common year. So we have the common years, and then we go into leap year. So the leap year is when we get the 366 days, which is 3/4 a day over a complete orbit. So the leap year makes up for the lost days that we lose from the common year. So we have the sidereal year, which is when the Earth orbits the whole of the sun. We have the tropical year, which goes from the vernal equinox to the vernal equinox. And every 72 years, the vernal equinox gets 1 day earlier as well. And then we have the common year where we start to lose a bit of the days. And then the leap year comes after the common years, which makes up for what we've lost in the common years. And so that's why we get the 366 days, which is 3/4 day over a complete orbit.
Whoa, I think we need a round of applause for Sonia. Sonia,
I never knew, apart from the leap years, I never knew any of that other stuff existed. And I was so excited to try and explain that as well.
And you did it beautifully. I think you've missed your calling as a lecturer, actually, Sonia, because the way that you explain stuff just has me completely riveted. You've got such a lovely way. Are these all the slides that we've got, or are there more?
Because the last one's the video, and I want to do, so that's the year. So that's the years that I've explained. It's the 365 days long, the sidereal year, the tropical year, the common year, and then lastly the leap year. There we go. So the season all depends on the Earth's axis. It's tilted about 23.5 degrees looking towards the sun, but it also depends on the latitudes where you are. So the more near to the poles you are, the more to the equator, the further north, the bigger the difference you will see in the seasons. For example, if you go to Finland, you'll have 8.5 hours in December, but in June, but then in December you'll have less than 6 hours of daylight. And if you go more to the equator, you have the same daylight and you have the same darkness throughout the year, and it is extremely warm. So you don't see any difference really when you go to the equator. And then the more near to the poles you go, such as Alaska, in between May and August, the sun will never set. You'll have daylight throughout I think it's mid-May to about the beginning of August. And then through November to January, the sun doesn't rise at all. It's just complete darkness, and it's extremely cold. So depending on where your latitudes, how far you are from the equator, the poles, it all depends on what the seasons you get. But for us, because of how the Earth goes around the ecliptic orbit around the sun, is how we get the seasons at each. It's like each quarter of how you see it in the little display there, a little quarter of it. So in December, it's the sun shines mostly in the southern hemisphere and not in the northern hemisphere. In March, it's like equally in both hemispheres. June, it's directly above the northern hemisphere when we have the longest day and the start of summer. And in September, it's equally both back on the hemispheres. So this is when we can play that little video. So I found a video on YouTube with we've got SciShow. He explains it really nice.
The chances of this video working are zero.
I
See,
know.
it's just a blank slide, I'm afraid. Oh no, hang on, what's that?
Oh, hang on. Does it have a display? Does it have a play button?
No, it's just a thumbnail by the look of it, Sonia.
Oh no.
That's it. Oh, I think you've done a lovely job of explaining it anyway.
Yeah, so there was a nice explanation on there. If you Google SciShow, and it does a good explanation of how the Earth tilts and the points of each because a lot of people, he said in the video, a lot of people think the sun is closer, the Earth is closer to the sun, and that's why we get summer, and people think it's far away in the winter when it's not. That is because of how we are on an elliptical orbit of the Earth's tilt, and how the sun's rays come towards the Earth, of how it goes up, and how the rays go down as well, of how we get the seasons.
Woo! Okay, so moving swiftly on, because I'm getting actually bone ache. It's so cold in here. Have you got the weather, Sonia?
Oh yes. So the quick forecast tonight is tonight you're benefiting more in the southeast and like Norwich, London area. However, through the night, some those rain, wintry showers will come by. We won't get rid of them here in the northwest or Wales or the northern England. They are pretty much here. Tomorrow's not looking too bad and dry. However, it's like the opposite. It's nice and dry during the day, but then by the time the night comes, that rain's coming in, it's getting cloudy, and Sunday's just a complete washout for the north as normal. But the south's looking nice on Sunday. That jet stream, it's still above, not moved anywhere. It's still over us, and it's looking to move above us maybe Tuesday, when we're looking to get at like 20 degrees Tuesday. We're looking for warm weather on Tuesday, but it's going to get cold again by Easter. No.
Thanks, Sonia. Ever since you've been doing this, all you've got is bad jet stream news. You'll have to have a word with it, love. Right. Okay.
It seems to be our best friend at the moment.
Okay, I'm going to go now because the jet stream is affecting the temperature of my toes right now. All right, Sonia, thank you so much.
Oh, you're welcome. I'm feeling the temperature in here tonight as well. It's definitely got colder in the conservatory at night.
See you soon. Thank you. See you next week, Sonia, for Easter. Maybe do one about Easter and the full moon.
Oh, yes. I'll see what I can come up with.
And we'll eat Easter egg live on air. Oh, I need Easter egg right now. Okay, see you soon, Sonia.
Oh, bye.
Bye. Okay. Sorry to shunt Sonia off like that, but my feet are getting to agonizing point. It's been a great show. Thank you, everybody, for sharing the video. Thank you to everybody who's participated in the chat room. We've broke a record tonight. This is the longest show. These shows only used to be an hour long, and now this is getting on for 2 hours long. Thank you to everybody who's contributed. Thank you, Jerry. I'm glad to hear stuff is all right for you. Thank you, Mr. ISS Above, for your very in-depth information. If you really want to get geeky on the ISS, I can highly recommend the ISS Above product, Raspberry Pi. Watch last week's show to learn all about it from Liam Kennedy. I just think that ISS Above is one of the most perfect products of all time. It's just such a brilliantly technologically naive, inspirational product that's got no agenda other than just to inspire and dazzle people and to bring joy. I love it. Okay, I better go now. I've got to pack up. Do you want to see how much stuff I've got to pack up? I want to go home now. I've got a nice ice cold 0% Stella Artois waiting in the freezer for me. So get Liam Kent. I think I'm going to get Liam on again. I want him as a regular. Guess who I've got coming on, everybody? Guess who I've got coming on? Let me just check who's on next week. I might need a guest for next week, actually. We're on the 2nd of April. I've got Martin Whip. Oh, I spoke to Martin. He has been referred to me. We are going to be learning all about the resurrection of an amazing, beautiful, historic telescope. So that is going to be really good. And what's happening? Oh, it's my zip on the heater. Just checking I'm not setting on fire. On April the 16th, guess who's coming back? Why is it not in my diary? And maybe it didn't save. Stu Clark's coming back. Stu Clark, you know how good he is as my co-host. He is absolutely just the best co-host. So always excited to have Stu Clark on. Stella Artois. I did say Stella Artois, Jerry. Liam is going to come on again. Of course you would. If you know anybody who would like to come on Pop Astro Live, please spread the word. Tell them to join the society. Tell them to share the video. Tell them that Cosmo loves them and they will come a-flocking. I'll catch you all later. I'm going to press the off button now. I really need to go. I'll catch you later. Lots of love, popular astronomers. Mwah. Have some glitter lipstick all over your telescope. Bye-bye.